Welcome back. It's time for lesson 6 in our fractions unit, mixed numbers and improper fractions. In order for you to have success in this lesson, you should have mastery of our first lesson, our vocabulary, fourth lesson, which is equivalent fractions and simplifying, and our fifth lesson, which is modeling fractions. Okay? Why do you care? Manipulating these types of numbers are going to help you immensely in multiplying and dividing with fractions, and also just because your math teacher is going to want you to know. So if you're getting graded on it, might as well get a good grade. Goals for this lesson are going to be able to differentiate between mixed numbers and improper fractions, seeing them and knowing which one is which, converting mixed numbers into improper fractions, and then improper fractions back to mixed numbers. So let's take a look at what they actually are. Up here I've got a mixed number, a whole number with a fraction. A lot of the times, fractions can be parts of a whole or parts of a set. It's usually easiest to think of mixed numbers as a part of a whole, right? So if I have a whole number here, which is 2, it's like I have 2 whole pizzas. So I'm going to draw my 2 whole pizzas. I'm going to color them in. All right, here's my 2 whole pizzas. There's 1, 2, right there. And then I'm going to have this other pizza, right? But it's not a whole pizza, it's a fraction of a pizza. Okay, and the denominator tells me that there's 4 total parts to this pizza, but I've only got 1 of them. Okay, so that's what a mixed number is. It's just a numerical representation of the 2 wholes and then the fraction, and it puts them all together. Now, improper fraction is going to be the same sort of thing, but it's going to list it a little bit differently. Instead of counting these 2 wholes that we had before right here, instead of counting those 2 wholes in the whole number category, it's going to take them, move them into their little parts, and then count them in the numerator. Okay, so it'll have a larger numerator than a denominator. So we're just going to take these 2 whole pizzas, right, and I'm going to take this part. Now we know this one is already down to 1 section. We're going to use our denominator of 4 from before. Okay, we're going to cut each one into 4 parts because that's what the denominator tells us, the total number of parts in our pizzas, okay, or in our pie, or in some non-food form of fractions, but I'm obviously thinking of food right now. So what I want to do now is just count all of those things so we can see what to do. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Because remember, I only had the 1/4. Okay, I can't count this one or this one or this one because they don't exist. Okay, so that's going to give me 9 total parts out of 4 parts to make a whole. All right, so that's going to show us that 2 1/4 up here, 2 1/4 is going to be the same as 9/4. Great. So there's the difference, and that's how you write them. Let's move down here. We're going to talk about changing one into the other. So I'm going to give you a couple examples of changing mixed numbers into improper fractions. The first way I'm going to show you is by drawing pictures. This is really good for small numbers and not so great for the bigger ones, and we'll show you why in just a second. Okay, so let's look at this. I can draw this mixed number just like we did before. So I've got my 1 broken into 4 parts, my other one, and I'm going to have 1, 2, 3, 4, and I can only use 3 in this one because I don't have a whole one. 5, 6, 7. Okay, so that's easy. I've got 7 out of 4. You're saying, why would I ever do that a different way? Well, as you start getting into bigger mixed numbers, this one isn't even that big, but imagine if this one said 13 and 7/9. You'd be drawing lots and lots and lots and lots of circles, and it's just not an efficient use of your time. Plus, your math teacher will want you to know how to do this otherwise. So I'm going to show you what we're going to do. Okay, we're going to have our whole number, our fraction. We're going to take our denominator, because that's how many parts there are for each one of these, and we're going to multiply. Okay, we're going to take our fraction, we're going to do our denominator times our whole number, and that'll give us how many parts there are in the whole numbers total, and then we need to add the numerator to it. So it's going to look like this. We're going to do 3 times 9, denominator times our whole number. It's going to give us 27 parts in the whole numbers, and then we're going to add to that our numerator. So plus 7 is going to give me a total of 34 parts. That's a 5. Let's erase that. 34. And what we need to do now is keep our denominator. Okay, the denominator is going to stay the same. So 9, keep your denominator. Very good. Now let's move on. We've done mixed numbers into improper fractions. Let's go the opposite direction. Let's do improper fractions into mixed numbers. Improper fractions into mixed numbers. And actually, I don't even have it written down here correct. So let's cross that out, and I'm going to write it properly. Converting improper fractions to mixed numbers. Okay. Remember when I said mixed numbers are easiest to think of as parts of a whole? Well, improper fractions are usually easiest to think of as parts of a set, and I'll show you why. Right here it says I've got 16 total parts. So all I want to do for the easy way is just write 1 to 16. So I know I have all my parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. I didn't really space that out too well there. And that's going to be another limitation of this. As you get into the bigger numbers, this is going to be really hard. But to start out and get a concept of it, that's fine. Now remember I said parts of a set. To make one full set, our denominator tells us that we need 5. So I'm going to go down, count 1, 2, 3, 4, 5, and there's 1. And then I'm going to go down 1, 2, 3, 4, 5. There we go. And I'm going to need 5 of these, so I'm going to take these 3, and then 14 and 15, I'm going to put them together. And I'm left with just one little lonely part, number 16, out there on the edge. So this is going to give me 1 whole set, 2 whole sets, this is 3 whole sets, and 1 extra. So that would give me 3 wholes and 1 out of 5 parts. Okay, you can see that with a bigger number, like this one down here, 67/12ths, it's going to be too much writing, okay? Too much writing. So I'm going to show you how we should do this one. The way we're going to do it is remember that fractions are actually just a division problem. It's a numerator divided by a denominator. So I'm going to put my 67 inside right here. I'm going to divide it by 12. Now 12 does not fit into 6 at all, so I'm going to put a 0 up there. And I'm going to concentrate on moving 12 into 67. Now I know that 12 is going to fit into 67 5 times, so I'm going to put that down. If you don't know, practice your multiplication tables, practice division tables, okay? Get some flashcards. It's time to be able to do that like this, okay? With a little practice and a little effort, you'll be able to do it no problem. So 12 times 5 is 60. I need to subtract that out. That's going to give me 7. Now we're going to put 5 with the remainder of 7, because that's what we had left over. And now our work is done, okay? Our 5, that's our whole number for our mixed number. Okay, the 5 is going to be our whole number right there, and our remainder is the parts left over, so that's 7. And just like we did when we converted one way, we're going to keep our denominator. So I have 5 and 7/12ths. It's that easy, just a little division and knowing which parts to put where. So reminder, keep your denominator, the 12, keep your denominator, move your quotient, the answer to your division problem, to your whole number, and take your remainder and put it in the numerator spot, and you'll be all set. Thanks very much. Good luck.